What I want to do in this first lesson is talk about the concept of biological molecules. Now, this means giving us a bit of an introduction to some of the basic chemistry behind A-level biology. And what we're essentially going to do is take an introduction to some of the foundational concepts for the study of A-level biology. And this means focusing specifically on the nature of chemical bonding to form these biological molecules. So we're talking about biological molecules in this lesson. Now, biological molecules can be formed mainly through three different processes that you should be familiar with, at least somewhat, from GCSE chemistry, and you might have some familiarity if you have taken A-level chemistry as well. So we're going to begin by talking about the concept of covalent bonding, and then we will move on to look at ionic bonding, and then finally look at the concept of hydrogen bonding, which is one that might be a little bit more advanced, something that you might do if you have taken A-level chemistry, but not necessarily if you've done it at GCSE. So those are the three things that we're going to cover in this lesson. And we're going to begin by looking at the concept of covalent bonding and covalency. Now, there are a few different things that you should know, first of all, about where and when covalent bonding takes place. So first of all, covalent bonding only takes place between non-metals, between two elements that are of non-metals. So this means that we are talking about the right-hand side of the periodic table. If you look at the periodic table, you have the whole transition metals section, you have groups 1 and 2, which are metals as well, and then all the bottom of the periodic table refers to the more radioactive elements, so things like uranium, plutonium, etc., etc. All of those are metals. And then as you go to the right-hand side, as you go through into groups 5, 6, 7, and 8, you're talking about non-metals. Now, that's where we see covalent bonding takes place. And what happens in covalent bonding is atoms will share the electrons that are in their outer shell. Now, this is something that we need to just very quickly familiarize ourselves with just before we move on to look at the other types of bonding as well. So when we talk about outer shell, we should note from GCSE that when we do chemistry, we should note that there are a certain number of electrons that every single element has in terms of the amount of electrons within the atom, and they exist in certain shells. So the way in which that you calculate the number of electrons that fit in each shell is that you take the case of 2 times n to the power of 2, where n is the number shell that we're talking about. So if we're talking about the first shell, that means we only have 2 electrons that fit in it. If we add this to our list, if we then move on and talk about the second shell, then that will equal 8 electrons that are allowed to fit in the outer shell, and then the third shell has 18, etc., etc., etc. Now, what happens is the outer shell, okay, will be where the majority of reactions take place, where electrons are shared and where electrons move from one element to another. And with covalent bonding, there is the sharing of electrons in order to fill the outer shell of each atom. Because one of the things that we should note that is important for chemistry and biology is that atoms like to have full outer shells. The atoms that have one electron in their outer shell, or maybe they have one left to fill in their outer shell, are normally the most radioactive of the elements because they really want to get that last electron in their outer shell. So let's take the example of H2O, which of course is water. How can we represent this using covalent bonding? Well, let's have a look at this. Let's just draw H2O for a second. So let's have this is the oxygen atom, and then we have a hydrogen atom, and we have another hydrogen atom here like this. This is how it would generally be represented. Now, oxygen has 6 electrons in its outer shell. So let's just represent these using dots for the oxygen atom. So I'll have 2 here, 1, 2, 3, 4, and I'm going to do 1 here, 5, and then 6. Okay, these are the atoms in the outer shell of an oxygen atom. And we know already from the fact that hydrogen is the first and the most fundamental of all the elements, they have 1 electron in their outer shell. So let's represent that like so. We have 2 X's representing the hydrogen of the hydrogen atoms. What happens then if we allow these all to share electrons? Well, what happens here is we have an electron here and we have another electron here, which means there are 2 electrons in this hydrogen outer shell, which means that the first shell of hydrogen is actually full because it only requires 2 electrons. The same can be said here with this hydrogen, and the same can be said for the oxygen atom, because we have 6 electrons plus these 2, which equals 8. And if you look back up here to this, the different shells, this is the first shell, this is the second shell, and you should note that there are 8 that fill the second shell. So all of these shells are filled as the result of sharing electrons. And so that is what covalent bonding allows to happen. So this essentially creates a system where we have this going on here, like so, where we have bonding here, and these represent the covalent bonds for H2O, for water. Ionic bonding is slightly different. And ionic bonding forms when ions are created. And we should know that ions are atoms that have one or too many, or too few electrons within their shell. So if they have too many electrons, they will have a negative charge because there won't be a balance between the protons and electrons within the particular molecule. If they have too few electrons, then there'll be a positive charge because there'll be more protons than there are electrons within the atom itself. And when ions are formed, that therefore means that they have positive charges. And if you have 2 ions that have opposite charges, because opposite charges attract, they bond together and form ionic bonds. Now, this occurs when we have a metal and a non-metal, and usually quite reactive metals. And the example we have here is NaCl, so sodium chloride. Let's have a look and use this as an example of how we would represent this through ionic bonding. Well, we would start by having Na right here, and we would draw, oopsie daisy, and we draw square brackets around the molecule itself. And we should note that the sodium has 1 electron in its outer shell because it's in group 1 of the periodic table. So we would draw a little dot. If we just draw a little dot to represent, this is the 1 electron in the outer shell. I'm not going to draw all of the shells and all the electrons because that would take too much time. And then we're going to add into this equation, the chlorine. Now, chlorine is written here. Chlorine has 7 electrons in its outer shell. Okay, so we have 1, 2, 3, 4, 5, 6, 7. Okay, you can probably see what's going to happen here. This one has 1 electron in its outer shell. This one has 7. So it would actually make sense for everyone involved in this little transaction for the 1 electron to move over to this side and to fit nicely here like so. And so that's what essentially happens. This 1 electron moves over to the chlorine and we get a pair of ions, because if this electron is moved over to this chlorine, then that means that there'll be more electrons here than protons with chlorine, which means we form a chlorine ion. We form a chlorine with negative charge. And equally, if we leave this electron and take it over to here, then the sodium will have 1 too few electrons, so it will have a positive charge. So we end up with the sodium here. I'm not going to draw the previous shell, but we should note that the sodium here will have a plus charge. And then if we then add into this the chlorine, which will have a negative charge because it will have these electrons here. This is what chlorine looks like in terms of the number of electrons. And then it has this additional one that's come from the sodium. And so therefore we have a positive ion and a negative ion, and they are attracted to each other to form NaCl. And this is how we get ionic bonding for this. Finally, let's just talk about hydrogen bonding. Now, hydrogen bonding is a little bit more advanced for I believe most people. You often do not do hydrogen bonding at GCSE, I don't believe. And what hydrogen bonding is where there is an uneven distribution of charge within a molecule. Molecules of course, are quite complicated, and they grow ever more complicated as we go on studying more and more complicated complicated things. And as you have more and more molecules that have different complex structures, you might find situations where there is an uneven distribution of charge across that molecule. There could be parts of the molecule that have more positive charge than negative charge, just because there's a higher concentration of electrons in one area, so therefore there'll be more negative charge in that area versus more positive charge where there is a less concentration of electrons in one area compared to another. And this can create a disbalance, an uneven distribution. And when we have a molecule that has an uneven distribution, we say that the molecule is polarized, or that it is a polar molecule. And so let's give an example of how this takes place. We can look at H2O molecules to come to this conclusion. Let's draw two H2O molecules right here. So let's draw one H2O molecule here, and then, oh, it's glitching out a little bit, and then we'll just draw the molecule itself. There we go, if it stops glitching out. Okay, and then let's just draw one other one down here, but let's just draw it like this. So we have the oxygen, and then we have the hydrogen, if it doesn't glitch out anymore, and then another hydrogen. Let's see what we're thinking about here. Okay, let's see what's happening in this particular situation. In this instance, we have two covalent bonds in terms of the two molecules that exist, but the hydrogen is giving up an electron because it is sharing it with this oxygen one over here. So there's actually no electrons around this side. But on this occasion here, we have a lot of electrons because we have an oxygen with an outer shell that is full of electrons because it has the hydrogen sharing that we have on this side. So there is therefore a disbalance in terms of the charges between these two regions. So we would write a little shorthand thing here. We write this as positive because this region has a positive charge, and we would say that this region has a negative charge, and so therefore there is a bond that exists between these two here that creates what we call hydrogen bonding, as we can see here. Now, in the next lesson, we're going to talk about further biological molecules that are important for our study of biology, essentially. We'll focus on the concept of polymers and polymerization and give a couple of examples of some of the different types of polymers that we can explore when we are examining biological molecules.